Welcome to the lecture on excitation due to support. So here in this case we have a system that is on a support and the support is vibrating. So the frequent example is the earthquake. So if there is some earthquake and there is a building, the earthquake motions will impart some vibrations on the floors of building. So here are some cases, like if you have some vibration on the ground and you have kept some machine on the ground, so there will be some vibrations due to the ground excitation and the amplitude of those vibrations we have to measure. So let's take an example. So we have a mass M, that is a system on which we are going to measure the vibrations, and it is supported by a element stiffness of K, then damping coefficient of C, which is rested on a ground, and this ground has excitation. Let's assume this excitation as harmonic excitation of y sine omega t. The amplitude is y, and due to this excitation there will be some response vibration of system, or that is mass, say x. So we'll first draw the free body diagram of mass. The acceleration of mass will be in downward direction, as we have to assume, or we will assume, that x is greater than y. So acceleration of mass will be in downward direction, and due to that the spring force will act in upward direction. Also the damping force also acts upward. The spring force will be the spring constant into the displacement of spring. The displacement of spring will be the relative displacement between the ground and mass. As we have assumed x is greater than y, hence the spring force will be k into bracket x minus y, and the relative damping force will be c into bracket x dot minus y dot. So let's write the equation of motion. The equation of motion will be mx double dot is equals to minus k x minus y minus c x dot minus y dot. Mx double dot plus cx dot plus kx is equals to, this will be ky plus cy dot. As we have assumed y is equal to y sine omega t, y dot will be y omega cos of omega t. So the equation will become k y sine omega t plus cy omega cos omega t. So that will be y into bracket k sine omega t plus c omega cos omega t. To simplify this, we will assume a right angle triangle of side ck and c omega and the angle alpha. The diagonal will be square root of k square plus c omega bracket square. From this triangle we can write tan alpha as tan alpha is equals to C omega by K. Then sin alpha will be C omega divided by square root of K square plus C omega bracket square, and cos alpha will be K divided by square root of K square plus C omega bracket square. So let's write the equations. That is mx double dot plus cx dot plus kx is equals to square root of k square plus c omega bracket square divided by square root of k square plus c omega bracket square, y into bracket k sin omega t plus c omega cos omega t. So it will become y square root of k square plus c omega bracket square k divided by square root of k square plus c omega bracket square into sin omega t plus c omega divided by square root of k square plus c omega bracket square cos omega t. And from earlier equations we can write it as y square root of k square plus c omega bracket square into bracket cos alpha sin omega t plus sin alpha cos omega t. And this relation we can write it as y square root of k square plus c omega bracket square into bracket sin of omega t plus alpha. So that will be the expression mx double dot plus cx dot plus kx. So let's take the response x as x is equals to x sin omega t plus alpha and a phase angle of phi. The response x for forced vibration of f naught sin omega t, that is like this system which is having a forced vibration of f naught sin omega t on system of mass m, is given by f naught divided by square root of k minus m omega square bracket square plus c omega bracket square. And in our case the particular excitation due to support is y sin omega t plus alpha, and in this case the particular amplitude is y square root of k square plus c omega bracket square. So we will write as x will be y bracket k square plus c omega bracket square divided by square root of k minus m omega square bracket square plus c omega bracket square. So x by y is equals to, we will take the common k bracket 1 plus c omega k bracket square divided by k bracket 1 minus m omega square upon k bracket square plus c omega by k bracket square. So here we will simplify c omega by k as c omega by k is equals to c by cc into cc into omega by k. So c by cc is zeta into cc is 2m omega n into omega by k. So root k by m is omega, then m by k will be 1 upon omega n square. So 2 omega n into omega into 1 upon omega square. So that will be 2 zeta omega by omega n, that will be 2 zeta r, that is r is a frequency ratio, that is omega by omega n. So that will be, the equation will be x by y is equals to square root of 1 plus 2 zeta r bracket square divided by square root of 1 minus, so that m omega by k, that will be also omega square upon omega n square bracket square plus 2 zeta r bracket square. So this will be square root of 1 plus 2 zeta r bracket square divided by 1 minus r square bracket square plus 2 zeta r bracket square. Now here so this is the required expression where x is the amplitude of response of a single degree of freedom system due to support excitation. So this will be the all for this lecture. In next lecture we will solve some problems on support excitation. What kind of problems will be there in the exam, we will solve in next lecture. Thank you.